Have you ever asked yourself why the rule for subtracting integers makes sense? In this video, we'll illustrate the subtraction of integers on a number line in a clear and intuitive manner so you never have to ask that question again. The key to doing this is using the correct definition of subtraction. That definition is finding an unknown addend when the subtraction is written as addition. In this video, we'll describe that as finding the difference between two numbers. In the past, the failure to use this correct definition is why it's been so hard to illustrate why this rule for subtracting integers is used. Subtracting an integer is the same as adding its inverse. This video will illustrate very clearly the origin of that rule so that it can finally be understood intuitively using a number line. And, based on this rule, there's some great news at the end of the video, so we encourage you to stick around until the end. But first, we'll look at all the possible combinations of positive and negative integers to illustrate the generality of this approach. We'll start with this example. The first example is subtracting a negative integer from a positive integer. We start by writing this subtraction equation with an unknown addend, like this. As a reminder, the numbers we add are called addends. We don't know what number this addend is, so we call it the unknown addend. In this video, we'll refer to it as the difference between the two numbers we know, or the unknown difference. This shows that to find the unknown difference, we ask the question, what number do we add to -2 to get positive 5? That's the mathematically correct definition of subtraction. It's how we find the difference between two numbers when we write subtraction as an addition statement. To find the difference, we start by putting positive 5 on the number line. Then we subtract -2. Notice that we placed both positive 5 and -2 on the number line, starting at 0. As a reminder, we show this subtraction symbol below 0. When we show each number starting at 0, that allows us to illustrate the difference between the two numbers we're subtracting, -2 and positive 5. On a number line, that difference is the distance between the two endpoints of the arrows for these two numbers. But there's one other thing we need to know. It's the direction in which we count. The direction we count tells us whether the number we count is positive or negative. To determine the direction, it's helpful to use this reminder. We start at the number we subtract. In this example, that's -2. Then we count to the number we're subtracting it from, which is positive 5, like this. That means we can fill in the blanks in the two equations above, because the answer to each problem is positive 7. Now, let's see what this looks like on a number line when we apply the rule for subtracting a negative number. We start by putting the numbers we're subtracting on the number line, positive 5 and -2. The rule says we start by changing the sign of the number we're subtracting, which changes it to its inverse. The inverse of a number is counted in the opposite direction from the original number. We show that like this. So we start by changing -2 to positive 2. Next, we add the inverse of -2, which is positive 2, to positive 5, which we show like this. The plus sign indicates that we're adding two numbers, positive 5 plus positive 2. You learned in an earlier video how to add two numbers on a number line. If you haven't seen that video, please subscribe to see all the videos in this series. And please click the like button also. To find the sum when we add two numbers, we always start counting at 0 and count to the endpoint of the second addend, which is positive 2. We show that like this. So, 5 plus 2 equals 7. Here's a quick review. We changed -2 to its inverse, which is positive 2. Then, we added the inverse to positive 5. Since we're now adding instead of subtracting, we need to find the sum, which is shown by the red arrow. It's positive 7. The result is the same in each case. The difference when we subtract is the same as the sum when we add using the rule. So, when we change the sign of the number we subtract, and then add that number, which is now positive 2, to positive 5, we get the same answer in each case. It's positive 7. The dotted lines show that the results are the same for the original subtraction problem and the addition problem when we applied the rule. So now we have shown why the rule for subtracting an integer makes sense. Subtracting a number, negative 2 in this example, is shown on the first number line. The second number line shows what we get when we apply the rule for subtracting a negative number. The rule says subtracting a negative number is the same as adding the inverse of that number, which is positive 2 in this case. The difference in the subtraction problem is equal to the sum in the addition problem, and that's why the rule is used. It also shows why the rule makes sense. The rule says subtracting a negative number is the same as adding its inverse, which is what we have illustrated here. The distance from negative 2 to positive 5 is the same as the distance from 0 to positive 7. Using this rule, we can now rewrite the subtraction statement as an addition statement like this. We change the number we subtract to its inverse. Then we add the inverse, positive 2, to positive 5, and we get positive 7. This first example is one of 6 different situations involving subtraction of integers. In the remainder of this video, we'll look at all the remaining problem types that involve subtracting both positive and negative integers. In the first example, we subtracted a negative integer from a positive integer like this. 5 minus negative 2 equals positive 7. In the next example, we'll look at the opposite situation from the first one, subtracting a positive integer from a negative integer like this. Negative 6 minus positive 2 equals an unknown difference. We start counting both integers at 0, negative 6 and positive 2. Next, we write the subtraction as addition with an unknown difference like this. And we ask, what integer do we add to positive 2 to get negative 6? That's the distance from positive 2 to negative 6, which is also the difference in the subtraction problem. We start at the number we subtract. Then we count to negative 6. The red arrow shows the difference, and it's counted to the left, so the difference is negative 8. That means we can fill in the unknown numbers like this. Now let's compare the results when we apply the rule for subtracting an integer. We start with the two numbers we're subtracting. Next, we change positive 2 to its inverse, which is negative 2. Then we add negative 2 to negative 6. To find the sum, we start at 0 and count to the left to the endpoint of negative 2. So negative 6 plus negative 2 equals negative 8. The dotted lines show us that the result is the same in each case. The difference when we subtract is the same as the sum when we add using the rule. So again, this shows why we use the rule. It gives us the same result, negative 8, when we do the subtraction and when we use the rule. That means the distance from positive 2 to negative 6 is the same as the distance from 0 to negative 8. Again, using the rule, we can now rewrite the subtraction statement as an addition statement like this. We change the number we subtract to its inverse. Then we add the inverse to negative 6 and get negative 8. Now, we'll add this to all the possible situations where the rule applies. In the next two examples, both integers are positive. In the first one, a smaller positive integer is subtracted from a larger positive integer, which results in a positive difference. In the second one, a larger positive integer is subtracted from a smaller positive integer, which results in a negative difference. Here's the first one. Subtracting a smaller positive from a larger positive. Positive 8 minus positive 5 equals an unknown difference. This example is the simplest of all subtraction problems for integers. It's the same as subtracting a smaller whole number from a larger whole number, which we could also write like this. This shows that we can use the rule for subtracting integers with even the simplest subtraction problems. You might be tempted to think of this subtraction as counting back from 8 to 5 on the number line. However, as we pointed out in an earlier video, take away is not the correct definition of subtraction. And counting back is not the correct way to illustrate subtraction on a number line. The correct definition of subtraction is finding the difference between two numbers when we count in the correct direction, to the right or to the left. This makes subtraction much easier to understand. So again, we start by writing this as addition with an unknown difference. Positive 5 plus an unknown difference equals positive 8. Next, on the number line, we put positive 8 and subtract positive 5 from it, which shows the difference between positive 5 and positive 8 going from positive 5 to positive 8. So we start at positive 5 and count to positive 8. The result is positive 3, shown by the red arrow pointing to the right. Now, let's solve the problem using the rule for subtracting integers. Again, we start by showing the two numbers we're subtracting, positive 5 from positive 8. We change positive 5 to its inverse, then add negative 5 to positive 8. Also note that in this situation, we start by counting positive 8 to the right, but we count negative 5 to the left instead of to the right. To find the sum, we start at 0 and count to the right until we reach the endpoint of negative 5. So, positive 8 plus negative 5 equals positive 3. When we compare the two results, the dotted lines show us that the difference and the sum are the same on each number line. So, when we change the sign of the integer we're subtracting, and then add its inverse, we get the same answer in each case. It's positive 3. Again, this shows why we use the rule. We get the same result when we use the rule as when we do the subtraction. That's because the distance from positive 5 to positive 8 is the same as the distance from 0 to positive 3. The rule says that subtracting a negative integer is the same as adding its inverse. Now, using the rule, we can rewrite the subtraction statement as an addition statement like this. We change the number we subtract to its inverse. Then we add it to positive 8. And we get positive 3. Now, we'll add this to all the situations where the rule applies. Here's our next example. Subtracting a larger positive from a smaller positive. To show this, we've changed the order of the integers we used in the last example. So we start by writing this as addition with an unknown difference. 8 plus an unknown difference equals 5. On the number line, we start with positive 5. And we subtract positive 8. Then we ask, what integer do we add to positive 8 to get to positive 5? To answer this question, we start at the number we subtract, which is positive 8. Then, we count to the integer we're subtracting it from, positive 5. The distance is negative 3, as shown by the red arrow pointing to the left. Now, let's compare this to what we get when we apply the rule for subtracting integers. We start by putting positive 5 and positive 8 on the number line. Next, we change positive 8 to its inverse.
Then we add negative 8 to positive 5.
To find the sum, we start counting at 0 and count to the left to the endpoint of -8. So, +5 plus -8 equals -3. When we compare the two results, the dotted lines show us that the difference and the sum are the same on each number line. The difference is the same as the sum when we add using the rule. So again, this shows why we use the rule for subtracting an integer. It gives us the same result as doing the subtraction. That's because the distance from +8 to +5 is the same as the distance from 0 to -3. Now, using the rule, we can rewrite the subtraction statement as an addition statement like this. We change the number we subtract to its inverse.
Then we add it to +5.
And we get -3. Now, we'll add this to all the situations where the rule applies. Now let's look at the last two examples. In both of these examples, we'll subtract two negative integers. The first example results in a positive difference. The second one results in a negative difference. Here's the first one. Subtracting a smaller negative integer from a larger negative integer, which results in a positive difference. -3 minus -8 equals an unknown difference. Here, -8 is smaller than -3 because -8 is farther to the left on the number line. That means we're subtracting a smaller negative, -8, from a larger negative, -3. We start by writing this subtraction problem with an unknown difference, like this. -8 plus an unknown difference equals -3. Then we show each equation on a number line. We start with -3. And we subtract -8. We want to find the integer we add to -8 to get to -3. So, we start at the number we subtract, which is -8, and we count the distance to -3. It's +5, which is shown by the red arrow that points to the right. So we can now fill in the answer in each equation. It's +5. Now, let's compare this to what we get when we apply the rule for subtracting integers. We start by putting -8 and -3 on the number line. Next, we change -8 to its inverse. Then, we add +8 to -3. To find the sum, we start at 0 and count to the right to the endpoint of +8. So, -3 plus +8 equals +5. The dotted lines show that the difference when we subtract is the same as the sum when we add using the rule. So again, we've illustrated why subtracting an integer is the same as adding its inverse. We get the same result in either case. Now we can rewrite the subtraction statement as an addition statement using the rule. We change the number we subtract to its inverse. Then we add the inverse to the first addend. And we get +5. Now we'll add this to all the situations where the rule applies. Here's the last example. Subtracting a larger negative integer from a smaller negative integer with a negative difference. In the last example, we looked at how to solve this equation. In this example, we'll change the order of the integers from the example before. -3 is still larger than -8 because -3 is farther to the right on the number line. So in this example, we're subtracting a larger negative from a smaller negative. We write the subtraction problem with an unknown difference, which tells us the integer we add to -3 to get to -8, which is the difference between these two integers. We start with a number line and show -8, which is the smaller negative integer. Then we subtract -3, which is the larger negative integer. As always, we start at the number we subtract, which is -3. Then we count the distance to -8, which is -5, which is shown by the red arrow pointing to the left. So we can now fill in the answer in each equation. It's -5. Once again, we'll compare this to the result when we apply the rule for subtracting integers. We start with the numbers we're subtracting. Then we change -3 to its inverse. Then we add +3 to -8. To find the sum, we start at 0 and count to the left to the endpoint of +3. So, -8 plus +3 equals -5. We get the same answer in each case. It's -5. So again, we've shown why we use the rule for subtracting an integer. It gives us the same result as the subtraction we started with. That's because the distance that represents the difference in subtraction is the same as the distance that represents the sum in addition. Now, using the rule, we can rewrite the subtraction statement as an addition statement like this. We change the number we subtract to its inverse. Then, we add the inverse to the first addend. We get -5. Now, we'll add this to all the situations where the rule applies. You've now seen examples of all the different situations that can occur when positive and negative integers are subtracted from another integer. And now, here's the great news we promised earlier. From now on, you don't have to remember how to solve any of these subtraction problems on a number line, and you don't have to remember any rules for how to deal with the signs of integers when subtracting. That's because you now have only one rule that makes it all easier. All subtraction problems with integers can now be converted to addition problems by applying this rule. Subtracting an integer gives you the same result as adding its inverse. The other major benefit of this rule is that you no longer have to use subtraction at all. You can now change every subtraction problem to an addition problem by applying this important rule. And by now, this rule should finally make sense.